Hello everyone, and welcome back to the bench. Today we have a Yaesu FT-2900. It's a 2-meter VHF ham radio. Puts out 80 watts. These things are pretty desirable. They're discontinued now, but you can still buy them brand new a lot of places, and they push that 80 watts, and a lot of truckers like these use them for VHF and whatnot, but good for off-road guys or anything really. They're pretty much bulletproof, but I do get quite a few of them in, and 90% of the time they won't power on, and it's because of this front panel. It's usually somebody spilled coffee in it, it's gotten wet, and there's just corrosion all on the circuit board. The other reason these things have issues is people reverse polarity on the power. And what I just noticed in here, having a quick look at it, is that this diode has a big soldered gob on it. Somebody's been in here, so we'll see if that diode's shorting out. I'm gonna hook it up to the power supply, restricted current, and see what it's drawing, and we'll go from there. We'll see what's blown out on it, if the regs are any good, but chances are it's gonna be voltage regulators, maybe this, and probably some kind of switching transistor for the power circuit. But let's power it on and see what it does, and we'll go from there. Well, this is interesting, as it turned on fine. It's only drawing 0.25 amps. I've got it limited at 3 right now. It is on low power. It is hooked up to the older Motorola test set here. So, let's see what happens. It's not keying up. Let's try another mic just to be safe. What I've found with this is that it's transmitting at full power, and it's not putting out much audio. You have to really scream into it to get anything out. So it could be, I've tried 2 different mics on it, so it could be something on the front end still. So what I'm going to do is, I have a few of these radios, so I'm going to swap over another head unit onto it and see if that makes a difference. And then I can determine really quickly if it's the head or the body. Well, I tried another head on it, and it was exactly the same. I tried this head on the known good radio, and it worked fine. So it's something in the body here, and it's going to be in the mic circuit, the audio circuit, probably the preamp, something like that. It could be that one. Now, I'm just downloading the schematic so I can take a better look at this again. So I lost the schematic, but what bothers me is that someone's clearly removed this board before. There's the Arctic Silver heatsink compound in there, and we have this bodged diode, which bothers me. So, other than that, the top end looks fine. I don't know what the bottom end looks like. That does look like a lot more solder on that can as well. Let's take a quick look at the schematic and then probably open this thing up and see if there's anything obvious on the other side, and then we'll just get straight to metering. Now let's look at this block diagram for a minute. Here's our mic jack. We are going to be going anywhere from here in the control head, which then jumps across this ribbon cable, which I've checked out to be okay. And then from there, it goes over to the mic amp, which is something else I want to investigate. Then into this digital to analog converter, where you can see here it's mixing in the DCS and tone and code, whatnot, which I believe is working. So we can investigate this mic amp here, Q1049, and anything on the way or between the mic amp to the mic jack. That is most likely where our issue is, and that's where I want to start. But first, just because this thing has been clearly screwdrivered before, I want to check a couple things out, because I noticed the tin can over the VCO block had way too much solder on it. So somebody has opened that before and caked it with solder, and I want to know what they were doing in there, and I just want to go over the microscope, see just any kind of weirdness that might be obvious before I go pulling this Q1049 and taking measurements. Well, after doing some investigation, I unsoldered this can, and I'll show you under the microscope what I've discovered. I don't know if this was the previous guy or if it was me being sloppy, but I'm willing to think both. And I'll show you what I mean on the microscope here in just a second. Bear with me until I come up with a better solution for this microscope. It does have recording option, which I will take care of. I just don't have an SD card that seems to want to work in it right now. So if you can see, this is where the solder was holding the tin on. And here we have a trace that is gone. And then this other one that is just hanging in there but exposed. Now, when I was wicking this with the solder wick, I was a little rough, but I don't think I was rough enough to destroy this track. So I'm thinking that this grounded out tin can solder here was touching one of these lines. And it's very possible that it could be our problem. Why? Well, I'll show you. Just so happens that one of those messed up traces happens to be our mic in or mic gain in for Q1043, which is our is that one our DA chip? 1043 is our DA, and they just happen to go over to Q1049, which is our mic amplifier chip. Both of those broken traces just coincidentally happen to be in this chunk here, so it's a very good chance that that is it. So what I'm going to do is some bodge wiring here, and we'll figure out a way to bypass those two traces. So before I do my little bodge wire connections, I've found here where two traces are, this one and this one. So from this ring and this ring, I will be basically cutting that out in the crudest of fashions. Because even though I'm going to coat those exposed traces that were damaged, there's still a chance they can get gooped with solder from that tin can, that RF shield. So I would like to make sure I break it here as well, just in case they get shorted out. Connecting the other ends of the bodge wires. let's put this back. Kind of assuming it's all good. Okay, let's try this out. Got it all assembled. Back to our test frequency. Audio check 1 2 3 4. Audio check.
Audio check 1 2 3 4. Audio check.
Awesome. That's another one fixed. And off the bench. So let's dig in the pile and find something new. Thanks for joining me today. And remember to like and subscribe.